I'm Ann Stinnett. I am Math Specialist for Knox County Schools, bringing you 8th grade math for week 6 of KCS at Home. This is going to be our final week of the KCS at Home videos and packets, and we're going to jump right into it because we have a lot to do in our last activity for this time. If you were with us during week 5, I left you with a challenge at the end of the video, and it was to figure out the formula for a pattern or a function. And this one was a tricky one, so if you were able to do it, congratulations. This was tough because we've been talking a lot about linear functions, but this one was not linear. We actually ended up with a quadratic expression, which is a little taste of what you might do in algebra. There's a bunch of ways you could have figured this one out. But I started with looking at the first column in each image, which I've marked in red on my slide here. And I noticed that I kind of worked backwards, that in the third step, there was 4 squares in the first column. In the second step, there were 3 squares. And in the first step, there were 2 squares. So that told me right there that was the number of step we were on, plus 1. So I knew the red represented n plus 1. And then I started playing around with a relationship for the remaining squares in the remaining columns. And I noticed that if I took that n plus 1 number, so in this case it would be 4, and if I cut that number in half and multiplied by the number in the step, it gave me the number of squares in the remaining columns. So I kind of wrote that out. I took the number I was on, multiplied it by half of the number in the first column, which was n plus 1. And if you simplify that expression and combine like terms, you end up with half of n squared plus 1.5 n plus 1. And that's a nice quadratic expression that explains this pattern. This week's topic is going to put together a lot of the things that we've been doing thus far with 2 activities that are based on a scenario or kind of a real life problem. And we're going to continue our work with proportional relationships and functions. So the things that we're going to be doing this week will be interpreting representations of a proportional relationship and a unit rate. We're going to make connections between representations, graphs, tables, equations, analyze changes in the quantities in a linear relationship, and identify how unit rate is represented in an equation. And back to our standard from last week, interpret rate of change as initial value of a linear function in terms of the situation it models and in terms of its graph or a table of values. So we're kind of synthesizing all of the things that we've been doing with relationships and functions. So to review some of the key vocabulary, a proportional relationship is one where the 2 variables have a ratio that's equivalent. So the examples on the screen, you'll see this first relationship. My input and output, my x, y values, are all going to create equivalent proportions or equivalent ratios. So 1 to 3 is equivalent to 2 to 6, equivalent to 3 to 9, 4 to 12, and 5 to 15. All of those are equivalent ratios, and you'll notice the graph goes through the origin, or 0, 0. For a non-proportional relationship, in this case, 1 to 2 is not equivalent to 2 to 3, or 3 to 4, 4 to 5, etc., and the graph does not go through the origin. Now, while this still represents a function, it is not a proportional relationship. The next thing we have is a unit rate. A rate is simply a ratio of 2 measurements, and a unit rate is one where the measurement is 1. So for example, I could say 24 inches for 2 feet. That's a rate, but a unit rate would be 12 inches per foot, or 12 inches to 1 foot, or $25 for 1 ticket, $25 per ticket. And a linear function is one whose graph is a straight line. We've been talking about linear equations, linear relationships, and linear functions this whole time. And typically we write a linear function in y equals mx plus b form. The independent variable is x, that's our input, and the dependent variable is y, our output, and that always depends on x, or whatever we're putting into the function. So in the example, we have our rate of change, which if that rate of change is over 1, it is a unit rate. And then we have, in our graphs, we have one with a negative slope, represented by this negative x, and we have a linear function with a positive slope, which is 1/2 x. Neither of these are proportional, because they have a starting value and they do not go through 0, 0, but they both represent linear functions because of that constant rate of change. For our first activity this week, we're going to be looking at a situation with a video game. And just to let you know, this first activity is a lot of what you learned in 7th grade. We're just going to be interpreting the table and looking at it in different ways to really break it apart. And then we'll be applying more of your functions review in the second activity. So the first one starts with Leo likes playing a video game where he has to zap zombies and turn them into statues before they invade a town. In the game, zombies hide everywhere. Leo's goal is to clear all the zombies to make the town safe again. To advance to the next level, you have to zap all the zombies in that level. Each level has the same number of zombies, and you get the same number of points for each zapped zombie. So there's your constant rate of change. As you move through the levels, the zombies get harder to zap. Leo made the table below to show a relationship between the number of zombies zapped and points earned. So let's just take a minute to make sure that we understand the table. The top row is the level. So at level 2, Leo earned 7,700 points. At level 4, he had to zap 140 zombies to get through level 4 to the next level. Level 6, he had to zap 210 zombies and earned 23,100 points, and so on and so forth. So there's a constant relationship between the levels. They are increasing at a constant rate, as are the number of zombies zapped, as are the points earned. So take a minute, if you can pause the video, and complete the table. Fill in the missing values and look for some relationships and patterns in the table. The first thing you're going to need to do is describe at least 3 patterns. So I've added some questions to the slide that might help you do that if you're trying to figure out what those patterns could be. So think about, how are the level numbers changing in the table? How are the maximum number of zombies zapped changing in the table? And how are the points earned changing in the table? And if you get that figured out and you want to give yourself a little bit more to think about, the questions with the star beside them are just a little extra bonus questions. So for example, as the level numbers triple from 2 to 6, how did the number of zombies change? What happened? And how did the number of points change from 2 to 6? So in other words, what happens to the number of zombies zapped if we triple them, and the number of points earned if we triple them? What would you do if you needed to determine the number of zombies zapped at level 20, or what about level 5? So as you work through this one, try to answer some of the extra questions because it will help you figure out the relationships in the table. Now for number 2, I went ahead and included the table completely filled out. So some of the relationships you might have seen were that the levels were increasing by 2 each time. The number of zombies zapped were increasing by 70 each time, and the number of points earned increased by 7,700 each time. So those were your constant rates of change in the table. You may have found other relationships or patterns in the levels to the points earned, and maybe the number of zombies zapped to the points earned. And we're going to explore those a little more in the next few questions. So to describe the ratios between the levels and the maximum number of zombies zapped, I've kind of put a red box around those two because those are the 2 rows we're going to look at. And how are those ratios related? So try to fill that out. You know the number of zombies zapped for every 2 levels of play. So how might you use that information to find out how many zombies need to be zapped at every level? Now, I noticed that 2 to 70, 4 to 140, 6 to 210, these are all equivalent ratios. So for example, if you could think about them like a fraction, which are not exactly the same, but I can think about them that way. If I multiply 2 times 2, I get 4. And if I multiply 70 times 2, I get 140. So those are equivalent. And I can use this to figure out what number of zombies zapped would be required for level 1. I can simply do 70 divided by 2, and that would give me 1 to 35. So that tells me that all of these ratios are equivalent, And the simplest form, if you want to call it, or the unit rate, would be 1 to 35. So in other words, I have to zap 35 zombies for every level. To push yourself further, what do you know about level 10? If I look at level 10, that's 350 zombies zapped. Based on that, what could I determine about level 5? Moving on to number 3, again, we're going to look at the ratios of the number of zombies zapped to the number of points earned, and how are those ratios related? Like the one before, how might you figure out the unit rates? How are the ratios related? You know the number of points earned for every 2 levels of play, so how can we figure out points per zombie? What's the maximum number of points you could earn each level? If I look at those and do some division, I'm going to figure out that it's 110 points for every zombie zapped, and it's 3,850 points per level. And I can simply divide those numbers in the table to figure that out. So a bonus question on this question, or this slide, would be, after playing for many hours, Leo had a total of 92,400 points. What level did he complete? Leo's little brother said he beat that level and zapped 990 zombies. Leo didn't believe him. Which brother is correct? Now, to figure that out, you might find yourself starting to derive some equations for figuring out these the answers, and we will get to those later. Number 4, we're going to name at least 2 different rates that you can find in this game. This could be any rate that you want. It's completely up to you. One example might be 70 zombies zapped for every 2 levels, and you could really choose any of the numbers on the table that you'd like. But number 5 is where we list the unit rates. And how do we know these rates are unit rates? If you know that you're doing your ratio out of 1, or for example, how many zombies per level? That's 1 level, that'd be 35 zombies. You could also say how many points per zombie, and that would be taking that unit rate of points earned to zombies zapped. Or how many points earned per level. Again, by dividing the number of points earned by the level so that you get 1 per level or 1 per zombie, then you have a unit rate. You might find some other unit rates, like how many zombies per point earned might not make sense in this context. You might get a fraction. Can't do a fraction of a zombie probably in a game, but they're unit rates that you could play with. And we know that they're unit rates when that second part of the ratio, or if it were a fraction, that denominator is 1. So bonus question here, if the bonus round scores triple points for every zombie zapped, and you earn 16,500 points in that round, how many zombies did you zap? So you could figure that one out by tripling your number. Number 6 is going to be to graph each rate and how they support your findings from question 5. So you're going to be graphing these and looking for the unit rate. And it might be tricky because unless you're using some software, like last week we used Desmos, you could completely use that. But for these, I just used a piece of paper. But before you look at mine, think about what labels you want to use for the X and Y axis. And I would suggest using the labels right from the table. The minimum and maximum values you would use. So for example, if I were going to graph the number of zombies zapped per level, how high do I want my x-axis to go, and how high do I want my y-axis to go, and what scale would be reasonable? I would recommend using a scale that kind of matches the rate in the table. So pause and make some graphs if you have the chance. If not, I'll show you mine. And just remember, if you don't have graph paper, if you take a piece of notebook paper and lay one horizontally and one vertically underneath it, you can see through the lines and it'll give you kind of some grid paper. That's what I did because I couldn't find my graph paper. So here is an example of the graphs that I made. And I used points earned for my y-axis in 2 of the graphs. One had the number of zombies zapped on the x-axis and the other had the levels. So again, you can see when I plot those points that they do form a linear relationship. You can probably see where I erased my line just to make sure that I had everything lined up properly. But you can see if I could drill down to the unit rate, I would see that I would have 35 zombies zapped per level right here on my graph. Now, some of these larger numbers might be more difficult to see. These are just my examples that I did on notebook paper of the graphs. And numbers 7 and 8 is time to write the equation for each relationship. And you might notice I went ahead and put the answers on here. You can use any variable you want, but I used L for levels, Z for zombies, and P for points. So in this first equation, the number of zombies zapped is 35 times the level you're on. So whatever level is 35 points per, or zombies per level. For part B, the number of zombies zapped and the points earned. So however, if I have 2 zombies, I get 110 points per zombie, and that gives me my total number of points. And the last one, the level in the game and the points earned, every level has 3,850 points that you can earn with those zombies zapped, and that means I could figure out the number of points based on the level that I'm on. So you might notice in all of these equations, the unit rate is what we are multiplying the variable or the dependent variable by. So that unit rate helped us to figure out our equation. Your second task this week is about some video streaming services, and we're going to use these to describe and create some functions. So the first one, you work for a video streaming company that has 2 monthly plans to choose from. Plan 1 is a flat rate of $7 per month plus $2.50 per video viewed. Plan 2 is $4 per video viewed. So think about that for a minute. On the surface, if you were shopping around for some video streaming services, it's easy to think, well, the one that has the cheaper cost per video might be the better option. But we're going to explore this a little bit and see what happens when we model these functions in some different ways. But first of all, what type of functions model this situation? They are linear because they are increasing at a constant rate. Nothing changes from month to month. They're always going to stay the same. So your first task here is to define variables that make sense in the context, and then write equations with cost as a function of videos viewed. So the number of videos viewed is going to be the independent variable, and then the cost depends on how many videos you view. So for each monthly plan, I chose C sub 1 as plan 1, so the cost of plan 1, and C sub 2 for plan 2, the cost of plan 2. So you can see my first equation is almost y equals mx plus b form, but I went with the starting value first. The commutative property says that's okay. So the starting value is $7 per month plus $2.50 per video, and I used V for my variable for video. You can use any letters that you want for your variables. For plan 2, it's simply $4 per video viewed. Now you might notice we have one proportional and one non-proportional relationship. When we graph these, which one do you think is proportional? Which one will go through the origin? And which one will have a y-intercept? For number 3, hopefully you've had the chance to work this out, because I'm simply going to go over the answers, is we need to figure out how much 3 videos in a month would cost for each plan and how many 5 videos would cost for each plan. So I simply need to substitute those numbers in for V, or my variable that represents the number of videos. So 3 videos on plan 1, if I substitute in 3, I'll get $14.50. 5 videos on plan 1 is $19.50. 3 videos on plan 2 is $12, and 5 videos on plan 2 equals $20. So take a minute to compare the 2 plans. What do you notice? Explain what advice you would give to somebody trying to decide which plan is best for them based on their viewing habits. So think about that for a second. Try to answer that. Pause if you can. But what I noticed is 3 videos on plan 1 is going to cost more than 3 videos on plan 2. But if I watch a lot of movies, 5 videos on plan 1 is going to end up being cheaper. And since it's a linear relationship, as I get on more than 5 videos, then it's going to remain cheaper. Because if you graph them on a line, that line is going to end up being steeper in the end. So depending on how many videos you watch would determine which streaming service is best. And this is a real life situation. When you look at things up front, you might, hey, right now that's cheaper, but in the long run, depending on what I need, this may not be the best option. So taking this a step further, part 2 is your cousin recently signed up for a competitor's video streaming service. So you decided to see what their plan cost. And you were able to find the following graph. So on the graph are the points 0, 9, 113, and 217. The first task here is to write an equation in slope-intercept form, which is y equals mx plus b, that represents the cost of videos using this plan. So in this case, you're going to take the difference in y values over the difference in x values, or rise over run. I simply did 13 minus 9 over 1 over 0, and that gave me 4 over 1 as my slope, or my rate. So that means this plan costs $4 per video, and when I put that in y equals mx plus b form, my slope was 4. So this tells me my cousin's plan is $4 a video. What does the 9 represent? On the graph, it represents the y-intercept, but in real life, in a video service, this would be the upfront cost. So for example, $9 per month just to have the video streaming service, plus another $4 for video. So let's compare that to what your company offers. If the initial value, or the initial cost up front, is already more expensive, I'm thinking this one's going to be more expensive. Also, it's $4 per video, so it's definitely more expensive in the beginning and in the long run. So you might wonder, in real life, why would anyone want to do this? What might be some advantages to a more expensive video streaming service? Perhaps they have better quality, perhaps they have better speed. I don't know. That's up to you to determine why you might want a more expensive video streaming service. But creating this function and describing it with a graph help us to see if we graphed the two services that we started with, we would notice that their lines would not be as steep as this line, and some might remain cheaper than the others. So again, a great way to interpret the information you have around you, especially if you're deciding to spend money over time. And the final thing I want to leave you with is something fun, something a little different to engage your brain. And this week's Math for Fun is called Cryptorhythms. And you can see they're from a website titled Enrich. And you can find these on their website. They have a lot of different family activities, activities with a partner, or these are called things to jot. But a cryptorhythm is simply finding a solution so that all of the letters represent a different digit and none of them can be 0. So for number 1, I figured out that A would equal 5. So in this particular equation, all of the A's would equal 5. 5 plus 5 plus 5 is 15. And B would equal 1. And there's several here that you can try out for fun. And if you want more to do, please check out on knoxschools.org under the KCS at Home resources. If you go to the supplemental resources tab, there are extra things there for all subjects, including math. Or you could go to departments, and the mathematics department homepage has some other things on it as well. And thank you so much for those of you that have been tuning in for all 6 weeks. I hope you have a wonderful rest of your day, wonderful May. Get outside, enjoy the beautiful weather, and I do look forward to seeing you back in school. Take good care. Bye-bye.